Session 8.6 Parametric Equations, Graph and Applications. Parametric equations of the plane curve. A plane curve is a set of points such that x equal to f of t, y equal to g of t, and f and g are both defined on an interval I. The equation x equal to f of t and y equal to g of t are parametric equations with parameter t. Parametric equations means that x will be equal to an equation in terms of t, and y is also equal to an equation in terms of t also. Look at this example. Let x equal to t squared and y equal to 2t plus 3. For t in the interval from -3 to 3, graph the set of ordered pairs x and y. So for this kind of the questions, we could make a table corresponding values of t, x, and y over the domain of t. Make sure when you make the table, the domain of t has to be included. Then plot the points. So you're gonna see the table. How could I decide what I'm gonna put for the t here? Usually, when they given the interval for the t, I was starting from this one, from -3 and then -2, -1, 0, 1, 2, 3. So you should have these numbers. And then I'm gonna plug in one by one. I'm gonna plug in -3 to t squared here to find out what is your x. So x equal to square of -3, which is gonna be 9. And then plug in -3 to the equation of y. Figure out what is your y here. So 2 times -3, which is -6, plus 3, that will be -3. Okay, right? Try to do it like one by one. Plug in -2 on the x equation and the y equation. Figure out what is your x and y. Second one, x equal to square of -2. So that which is gonna be 4. And then -4 plus 3, that will be -1. Okay, I want you guys try to do it by yourself and we're gonna try to work together. Okay, check your work. Okay, based on the table, you do have the x and y coordinate. Okay, you could put it on the graph here. You're gonna see the direction, right? This is means when t equal to -3, you got the first coordinate, 9 and -3. When t equal to -2, you're gonna get 4 and -1. So somewhere like here. So the arrows head indicate the direction the curve chase has t increase. Okay, make sure when you guys graph it, including the arrow head. Example 2. Finding an equivalent rectangular equation. Find a rectangular equation for the plane curve of example 1 defined as follows. So we do have the parametric equations, and I want to get out of t to find out the rectangular equation. So first thing we need to do, we want to eliminate the t. So it would be easier if we could solve the equation for the t using the y. So what we're gonna do, we're gonna subtract 3 for both sides and then divided by 2. Okay, right? Now we're gonna plug in t equal to y minus 3 over 2 into this equation. Okay? So x equal to y minus 3 over 2 squared. So you can see I eliminate all the t here. And this is gonna be my rectangular equation. Okay, and then I simplify a little bit. So 2 squared, that will be equal to 4. So I do have 4x equal to square of y minus 3. And since the t is in the domain from -3 to 3, we could calculate what is the domain for the x also. So think about it. When I plug in -3 here, I got a 9. When I plug in the +3 here, I also get the 9, right? So think about it. The domain will be from -3, -2, -1, and then 0. Okay, so when I plug in 0 here, x that will be equal to 0 as well. So I could believe that the domain for the x is going to be from 0 to 9. So the rectangular equation will be this guy for the x in 0 to 9. Okay, that will be under the domain x 0 to 9. Okay, example 3. Graph the plane defined by x equal to 2 sine t, y equal to 3 cosine t for t in 0 to 2 pi. We could try to find out the rectangular equation and then we can graph the equation. So what we're gonna do, we try to eliminate the t here. But since we do have a sine and cosine here, we may want to use the formula sine squared t plus cosine squared t equal to 1. Okay, so first we start with x equal to 2 sine t. And then we're gonna take square for both equations. So take square, you're gonna get x squared equal to 4 sine squared t. And then divided by 4 for both sides. So we already got sine squared t equal to x squared over 4. Now we're gonna take care of this guy. We take square again. And then we're gonna divide it by 9 for both sides. Okay, right? So now we could add up these two equations. So you do have x squared over 4 plus y squared over 9 equal to sine squared t plus cosine squared t. And we know that from the formula, this guy, that will be equal to 1. Okay, remember what kind of the equation is it? That will be the equation of ellipse. Okay, ellipse. If you guys remember that you learned it from the algebra, the general formula for the ellipse will be x squared over a squared plus y squared over b squared. And then the a, that will be equal to 2, b, that will be equal to 3. Okay, a equal to 2, b equal to 3. Note, parametric representation of a curve are not unique. In fact, there are infinitely many parametric representations of a given curve. So now look at this example. Give two parametric representations for the equation of the parabola y equal to x minus 2 squared plus 1. Okay, so we want to separate with two equations in terms of the t. So the easiest way, I will let x equal to t. Okay, x equal to t. When x equal to t, I plug it in. I'm gonna get y equal to t minus 2 squared plus 1. And the t, that's a no restriction. That will be from negative infinity to positive infinity. All right, this is one of the parametric representation for this equation. And other choice, I could let x minus 2 equal to t. Okay, x minus 2 equal to t. So x, that will be equal to t plus 2. Now, since I know x minus 2 equal to t, my y, that will be equal to y equal to t squared plus 1. And same idea, t will be from negative infinity to positive infinity. So we do have a two different parametric representation for the same equation, right? And sometimes we could use the trigonometric function because I saw there's a y equal to something squared plus 1. I may let x minus 2 equal to tangent t. So x equal to tangent t plus 2 here. Okay, when x minus 2 equal to tangent t, I'm gonna plug in here. So I will have a y equal to tangent t squared plus 1. And remember this formula, what is a tangent squared t plus 1 equal to? That will be equal to secant squared t. Okay, and then this time the t will be from negative pi over 2 to pi over 2. That's it.